Ahoy Captain, and welcome to this exciting episode of how to decarbonize your ship. If you have a RoRo cargo vessel and you're looking to add some little shore power to it, well baby, you are in luck, because today we're going to investigate this case for a RoRo cargo ship specifically, and we're going to dive into the details of FuelEU Maritime. What we're going to ask, what we're going to ask ourselves is how much would it cost, and thus how much would you save if you use a shore power connection for a RoRo cargo vessel. And we're going to call this case study the RoRo Lets Go, and of course when we're hooked up to that sweet old shore power, we're going to get 100% CO2 reduction when moored. Well, it all depends on how many days you are moored, of course, but in practice I've seen that for this particular case we're going to have about 15% overall on a yearly basis, including the sailing, in terms of CO2 reduction, which is still quite a lot. It costs about €1 million. Normally we would say about 300,000 per megawatt hour, but because we're going to go for a 3 megawatt rated installation, I'm guessing about €1 million. I'm going to show you where I get that number from, of course. The payback itself, we're going to see about 1 to 4 years payback, because, well, FuelEU savings will be roughly 250k per year. Well, are they really savings? If you have shore power, it means that this is the reduced penalty you will pay, and I'm going to show you exactly also here where I get those numbers from. Before we start, however, a few disclaimers from our part. The tools that we use are, of course, only a model. We do all the calculations. We now have very specific ship information available, but we don't have your ship, your operational profile, your needs, etc., etc. It's constantly evolving, and you're probably going to see that today if you watched another video of us as well some time ago. We're now constantly improving, hopefully, our tools, and we get more and more accurate and better and more valid information. And finally, it's made by humans. There can be small errors in them, just like a Bob Ross. We're constantly trying to repaint over those errors, but if you find any, please let us know, because that will only help us to give you better tools. And on a final note, everything that we found and use is made using publicly available data. So, that being said, we've done the disclaimer, so let's dive into the RoRo Let's Go. And for this case study, we're going to use 3 tools. That's right, we're going to first have a look at the average shore power demand for vessels to get an estimate on what a RoRo cargo vessel of this type and size, we're going to go for a large size, would actually use. We're going to check our ship database to get more information on a specific vessel that we are looking for. We're going to go for RoRo passenger ships, but I'm going to pick one that hopefully would be a good example for the rest. And then finally, we're going to input that information into our shore power quick scan in order to have a closer look at that sweet FuelEU savings, baby. But, well, you know what? Let me just show you first the average shore power demand, and then go to the end of the video in order to really narrow down the numbers. Here we have the membership page where we're gonna take all the tools from. So we have the database, we have the shore power quick scan, and under construction, the shore power average power demand tool. So here's the tool. I'm gonna directly go to compare multiple ships, because I want to get an overview of all kinds of different sizes of RoRo cargo ships first before I start. So I'm gonna go for RoRo ships. There we go. We have 3 different sources loaded in. We're still working on our sources, because we're gonna include maybe up to 1,000 vessels, their auxiliary power, and an estimate on what they would use, so that you get a good estimate of all those ships available. And as you can see, we're still bidding the small, medium and large vessels, but here we see that the low and average RoRo ship would be 690 to about 1,000 kilowatts. The high would be 6,500 kilowatts. That is very high, so let's see if I can filter that one. Here we go. That's also filtered on source, but we see that some extra large, or the largest RoRo cargo, could go up to about 6,500 megawatts. This is by EMSA, so what happens if we remove EMSA as a source? Then we see that we already have a very different picture, so it's very important to take the right assumptions. Getting that back in, if we see here, I'm going to go for roughly the average, like I said, about 1 megawatt of power on average while moored. And if you want, you can have a look and maybe even filter on dimensions, etc., or different sources. And again, we're going to improve this tool to help you further, but this already gives us a good range of where the average shore power demand would lie. So we're going to go for 1 megawatt and we're going to find a RoRo cargo ship that fits the bill. And here we have the sustainable ships database. We have about 10,000 vessels in our database at the moment. We're going to go for, of course, a RoRo ship. Let's see. We have plenty of ships available. Which one to choose from? We want to get something with auxiliary engine known. I'm going to go for the first ship that sails at 18 knots. Oh well, that's faster than I thought. 18 is one of my favorite numbers, so I guess we're going to go for the 16. Lovely. And then if we input more information, then we can get a lot more information also on main engines and auxiliary engines. That's also stated here, but at least we can check also for you if you have the right type of vessels and whatnot. So okay, we have our vessel. It's the 16, a roll-on roll-off carrier, 50,000 GT. That is a lot, 18 knots. And then we have one Hyundai of about 900 kilowatts. All right. And then we also have 3 different types of Hyundai Himson generators at 2300 kilowatts. So this tells me that that 900 is of a different size. So it looks like it's a different purposed engine. Could be an auxiliary engine, could be a generator, it could also be I don't know, a backup, but those 3 times Hyundai Himson, that's what I'm going for. 2300 at 40% load. Yeah, that's roughly a megawatt. At least one usually or typically is a spare, so that you can have 2 engines always running, one for a backup that can provide full load of about 2300, and usually they're running at a little lower load. At least this is also what I know from a similar case in Hook of Holland. They also have a RoRo ship with 3 megawatt connection. So this does look like a good one, but it's going to be hard if we don't have more information from the ship owner. So I'm going to make some assumptions and I'm going to input this information into the shore power quick scan. Let's check it out. And here we have the RoRo Lets Go. Well, this is just a reference ship. It is a RoRo Cargo, and we've inputted some information from the 16 in order to get a good comparison of a ship this type and size. So as you can see, we have an auxiliary power of 2300. The main power is used for propulsion, and we have made the assumption that it's on 6600 volts internally, 60 hertz, and everything is done by means of MDO or MGO, but that doesn't really matter too much. So if we're going to look at the power demand, here we see 2300, auxiliary engine load of 40%, which would lead to roughly an average power of 920. I'm gonna check to see if we did it correctly. 2300, yes, 20. Oh, okay, so the diesel engine is 2400 kilowatts connected to a generator of 2300 in terms of generated power. So this has to be 2400, and then we're gonna even closer get to 1 megawatt of power. If we have 960 kilowatt average power, then perhaps we only have to use 811 kilowatts in terms of electrical energy, because we can shut off the engine, pumps, heating, cooling, whatnot. Have a look and decide for yourself, or see what you have. Oh yeah, we're gonna add the name for this particular case, of course, because that's fun, and it also gives us a little bit more to work with. We have about 220 grams per kilowatt hour for this type of engine. That could be the case. If you have something else, you can always change, of course, the average fuel consumption, but we're gonna stick to 0 at the moment. And this all leads to, as you can see here, some averages. So normally we would consume about 566 metric cubic meters per day, 24 hours, if we are idling on board using these settings, and of course 0 if we are not. There's one more thing left to do. If we have a look here, I had a look at an example itinerary of a ship that would sail between the Netherlands and Ireland. It's a very nice route. And then the idle moored 200 days. Well, that is really a lot. So I'm gonna say about 20% of the time moored, 18% of the time. So that's gonna boil down to about 60 days, if I'm not mistaken. Roughly 60 days now, a little bit more, 62 days or 65 days. 65 days. And then we assume that it's not 100% uptime for the shore power installation or infrastructure. So it's a little bit less shore power. Sometimes we still have to go running on the generator. However, we do have shore power connection on both sides. In the future, I will show you how to incorporate onshore infrastructure into the business case. But for now, we're just going to assume that it's there. In terms of the equipment, I'm going to rate power to 3000 kilowatts, like I stated. Everything else I'm just going to leave as is. Well, no, I'm going to add switchboard modifications, but I'm not going to add a transformer. So I'm now going to assume that the power that comes from the onshore infrastructure is still the same as the same voltage coming in. Yeah, the grid voltage is ship voltage. Wow, that's not too hard, is it? No. So we have about 1 million in terms of CAPEX, but as I can see here, not really a business case. That means that it takes more than 10 years to get a business case. So, well, I'll have a look and see how we can improve there. Probably have to do something for the fuel or electricity costs. The CAPEX breakdown can be seen here. We have a line breakdown of all the different line items, transformer, and also the foundation itself is hence not required if we don't have such a transformer. Everything else you can change, add, or whatever you need to do. The biggest cost impact here would simply be the switchboard modifications, the shore power connection panel only on one side, because we're assuming the ship always is on the same side. Suffice it to say, you can change these parameters any way you want. And now for the interesting part, the OPEX breakdown. And as you can see here, yes, that's definitely the case. We do have some EU ETS and FuelEU savings for this reporting year. However, the electricity price here is simply too much. So what I'm going to do is I'm going to set the fuel price at the same level as the electricity price. And what I mean by that is I'm going to have it roughly, yeah, there we go. So we pay roughly the same amount of fuel as we do electricity, roughly. And then you can see that engine maintenance is limited and most of our benefits will be due to EU ETS and FuelEU, depending on, of course, the reporting year that we are going for. And as you can see, it really makes a big difference. And in the future, we'll also add different reporting years for EU ETS because there's a small change there as well. You can change all these parameters any way you like. Right now we're going to go for a business case and I'm hoping, yes, about 4 years in terms of payback with an electricity price of 25 cents, which is, well, depending on whether or not it's your own terminal, quite a lot. You can do with a lot less, but then maybe you have to buy some power purchase agreements, etc. What if we lease everything? This might be interesting, but it really depends on, of course, the lease period and the interest rate. That should be a bit higher. Yeah, well, no, in this case I'm not going to lease anything. This sounds better to me. All right, so before we dive into FuelEU Maritime, I guess one more thing left to say, because this is something that I'm not sure if I would be that excited for, because as a ship owner, 5 years of payback time, well, it is a long time, I have to say. So either we can reduce the total CAPEX in engineering, so let's see how that would decrease our price. We're going to go for 6 years CAPEX multiplier. So what if we only pay half to 3 years? Well, that kind of makes sense, doesn't it? So this would be better, but that also means that we have a maximum of about 500,000 euros in terms of maximum CAPEX investment. So I'm going to go back to the business case. This, of course, is only about 16% connected to shore power per year, 59 days, which basically means that for each hour that we are connected to shore power, we sail for about 4 hours, if not mistaken, because that's 20% of the total. What if we have more days connected to shore power? So we see that it's highly sensitive to more days connected to shore power. If we have only 23% connected to shore power, then we see that the business case is highly improved. And there's also something else I want to show you at FuelEU that's not really discounted here. But this already gives me quite the confidence in the case of a RoRo, that especially if it's moored for a longer period of time and we're not always sailing, there's also some layup periods, etc. So we really have to look into the operational profile. But this already gives me quite a good confidence that a business case, with given these prices, of course, can be made. Now let's go dive into the question that we have all been waiting for. What about FuelEU Maritime? First, we're gonna just stick to these parameters just to be sure and keep things the same, and then I'm gonna show you everything there is to know in the FuelEU Maritime tab. As you can see, normally a penalty in 2025 would be roughly 381,000 euros. That's the penalty over the entire year. But with this kind of shore power, it's only 1,000 euros. And I'm gonna check it out because that sounds dubious, but it isn't. No, this is crazily enough almost exactly at the threshold at which you get a greenhouse gas intensity that is lower than the required intensity, at which point you don't have to pay shore power. What it means is that here you see the amount of shore power fuel input EK in megajoules. And so if I'm gonna change this number, maybe if I change this to an 8, no, I need to change this maybe to a 3, or I need to change this to a 9. I'm almost there. I'm gonna change this to a 3, and then you see 0 euros. So if we have a certain amount of shore power per year, you're gonna go below the greenhouse gas intensity, which means you don't have to pay the yearly penalty of 381,000 euros per year. Multiplied by 5, that really is quite a lot. Multiplied with the 1.5 million you're gonna pay afterwards, you get a total 10-year FuelEU cost savings until 2035, 4-ish, of about 4 million euros, which is an amazing amount of money. Of course, the annual main consumption, the fuel type, everything else, we need to know for sure that it's correct and that it's indeed what this is. But here you see the 10-year FuelEU savings, and we have not discounted them properly, I'm not sure, but at the moment we're saying that only the 89 shore power days, so that's 89 divided by 365 multiplied with that yearly savings, is discounted here. Perhaps we should do it differently, because then FuelEU would even be a lot more beneficial to this case. But right now we said that not everything can be contributed to the shore power days only, because you're looking at the entire FuelEU year. Nonetheless, this is quite something. I mean, 4 million in 10 years. Well, have a look yourself. Change the numbers if you want. Change the annual main fuel consumption, and then you get different numbers. So let's see what the number would be if we're gonna decrease it to, again, about 60 days. So if we have 60 days, which is 18% shore power, lovely, we get about 3 million. And if we have almost 100 days, which is 30, well, 1.5 times more, 27%, we indeed get a little bit less than 1.5 times extra. So one day, I mean, okay, maybe I can check one day. How much would one day be? So one day would incur about 44,000 euros worth of savings over a period of 10 years. Let's see if that concurs with our OPEX here as well. Stack it up, stack it in. Yes, yeah, 1,000 euros per day. Yeah, that really is a lot. So if you want, you can save the case here, input your email, and we can send a report with the information. Of course, this is, I'm going to put it back to the good old days. There we go. So what do we know? 1,000 euro savings for this particular case, given the shore power consumption as stated in these power demand graphs, or the ship power demand graphs, which leads to almost 4 million euros of savings, let's say 250,000 per year for the first 10 years. I'm not going to look beyond that because that's too far ahead, but still, it looks very lucrative to have a shore power installation when it comes to FuelEU Maritime. If you've managed to watch the entire video, thank you very much for hearing me out. I hope you have learned something. Feel free to use the tools that we have. And of course, sign up if you want to make your life easier. You're not only able to use all the tools, get access to special premium features, you're also able to download the tools and get better cost estimates and scenario makings for your own models. Thanks again for watching this video and have a great day.